Hello and welcome to class. In this video, we'll be continuing our study on coordinate geometry of straight lines. But first of all, we have to run a quick revision of the few concepts that we have looked at. We've been studying the Cartesian coordinates, and we have identified that we can use it to represent the position of a point, all right, using the coordinates which are always in pairs. Alright, so when you have this as a coordinate 2, 3, remember that the first one is always for the x, while the second one is for the y axis. Okay, we've had to look at all that, and also recall that we have also had to look at the distance between 2 points on a Cartesian plane. So when we have, say, points, the P giving us 3, 2, and point Q being given us maybe say 5, 4. All right, so when we want to find the distance between these 2 points, we recall that we have the formula for that. There is a formula for evaluating the distance, so we have the formula to be d is equal to d standing for the distance being equal to the square root of, we have x2 minus x1 squared plus y2 minus y1 squared, all right, all square rooted, wherein in your P now you have the first x to be x1 and you have the 2 to be y1, all right, well in the cube you have the first number there to be x2 and the 4 to be y2. So you go ahead and substitute the values in this particular formula and you get your answer. All right, now also we have also looked at the midpoint between the lines on the Cartesian coordinates. When you have given points, maybe say point A to be 3, 4 and point B to be at 2, okay, let's say at 5, 8. Right, when we want to calculate the midpoint of this line segment on a Cartesian coordinate, remember that we have the formula being that the coordinates of the midpoint is given by this formula. Remember that you're going to have x2 plus x1 all over 2, comma y2 plus y1 all over 2. All right, so you have to add your x. This is x1, remember this is x2, not x2, x1, y1, and here is x2, y2. So we'll go ahead and substitute the values in this equation, and then the answer we'll get will become the coordinate of the midpoint of the line segment. All right, now for today, so this is like a quick revision of what we have done so far. Okay, so going for today, we want to consider the gradient of a straight line. Gradient of straight lines, also known as the slope of a straight line. So when you have on a Cartesian coordinates, right, as where you have x and y, let me use here, where you have x and y, this is like a graph book. So when you have your y axis and then you have the x axis, as the case may be, now when you have a line on the Cartesian coordinate, the line, this line, look at, okay, let me draw 2 lines. Look at these 2 lines. Let me even draw another one. Look at them. You see that this particular one is slopey, but not as slopey as this one, or steep. Then also you have this one also, which is the steepest of the 2 lines. All right, so gradient just tries to calculate how steep a line is, how steep or how slopey a line is. That is what we mean by gradients. And for any given line on a Cartesian coordinate that I want to calculate the gradient, this is the formula. The gradient is called, we use m to denote the slope or the gradient. We use m to denote the gradient, and the formula for calculating our slope m is given by this: y2 minus y1 over x2 minus x1. This formula here is what you are going to use to calculate the slope of any given straight line on a Cartesian coordinate. So what you need to do is identify your y2, identify your y1, identify your x2, identify your x1, then plug in the values in this equation, and that will give you your answer. So let's look at some examples. All right, don't forget this is the formula. So let's look at some examples. Say that we want to calculate, maybe you're asked to calculate the gradient of the line between the points. Maybe you are given points P as 5, 8, and you are given point Q as, let's say, 9, 10. All right, you are asked to calculate the gradient of this line, that is how slopey this line is. Now you know that the formula for the gradient m is given by this: y2 minus y1 all over x2 minus x1. What is our x1, y1, y2, y1? What is that? Remember, the first coordinate for your p, you always have x and y. In every given pair of the coordinates, the first value is always the x, second value is always the y. But now you have 2 points given, p and q. Each of them has x1, each of them has x and y. So that is why you have to label in the first one, we have to label this one x1, we'll label it x1, and here y1. While in the second coordinate for q, we'll label the first one x2 and y2. Having identified our x1, y1, x2, y2, we'll then come back to this formula and plug in the values. So going ahead to do that, our y2 is 10. All right, so we have 10 minus our y1, which is 8, over x2, which is 9, minus x1, which is 5. And this will give us 10 minus 8, that is 2, over 9 minus 5, that is 4, which will then go ahead to give us 1 over 2. So 1 over 2 becomes the gradient of this line. That is how slopey this line is. We're still going to look at the interpretation of the gradients. All right, so you're seeing that how we can be able to calculate the gradient of the line is when we have the values of the 2 pairs of coordinates. All right, so let's look at another example. Say we want to calculate the gradient of the line between given points A, 2, minus 3, and point B being minus 5, 2. All right, so we have these are 2 points that are on a Cartesian coordinate. So you have in the first point x, on the x-axis you have 2, on the y you have minus 3, second point you have minus 5 and 2. Then you want to calculate the slope of this line. What is the first thing that you do? You try to identify the x1 and the y1 in the given coordinate. So for your point A, the 2 becomes x1, the minus 3 becomes y1, while in the b, the minus 5 becomes x2 and the 2 becomes y2. y2. Going ahead to use a formula, we have the formula, let me write it again. M is equal to y2 minus y1. Remember that the m means the slope, that's the gradient. y2 minus y1 over x2 minus x1. So going ahead, our y2 is 2, right, minus our y1 is minus 3. Now note this, y1 is minus 3, so we have a minus 3 all over. Then for our x2 we have minus 5 as x2, then minus our x1 we have 2. All right, please note that when the value of the coordinate has a negative value, a negative sign, you must also include that, so you don't throw away the minus 3 here. So this minus that we have here is for the formula. Then the value of our y1 is a negative 3. That is why we have to include it. Now solving, we have that our m, which is the slope or the gradient, is equal to 2. Now minus into minus 3, that is minus times minus, that will give us plus 3 all over. Now minus 5 minus 2, that will give us a minus 7. And all together, what we're having is 2 plus 3, that is minus 5 over 7. And this becomes the gradient of this line. All right. So it boils down to knowing the formula, which is this, and also how to apply it. So in the next video, we'll be looking at how to interpret the gradient, giving gradients. But for now, try out the following practice question. So find the gradient between these points. Number 1, we have point P giving us 2, 3, and point Q giving us 1, 5. All right. For number 2, also try this gradient between 2 points A, 0, minus 5, and the point B, which is 2, 7. 2, 7. Finally, number 3, calculate the gradient of a straight line between the points 1, 1 and y 2, 5. Okay, let me vary that. Let's say 2, minus 5. All right, so try to calculate the gradient of these 3 lines that has been described using the points, their endpoints. That is, for the very first one, point P, Q. That is the line is going to be PQ. The starting point will be 2, 3. The end point will be 1, 5. We have looked at how to plot these points. Okay, we have had to look at how to plot given points. That when, for example, when we have this to be the coordinate, remember that here is the origin, and you have 1, you have 2, you have 3. Then on this side you have minus 1, minus 2, minus 3, and all that. Then going up on your y-axis, you're having 1, you're having 2, 3. Below you're having negative 1 on your negative y-axis, minus 2, minus 3, and so on and so forth. So here is our x-axis and here is our y. So if we were to plot, say we want to plot this value minus 3, 2, what that means is, remember that the first value x is for x, while the second one is for the y. So on our x-axis we'll look for minus 3, which happens to be here, right? And then our y-axis will look for 2, which happens to be here. Where do they intersect? They intersect at this point. When you trace it up, and you trace it up, this is where they intersect, where x is -3 and y is +2. So that's really how you interpret coordinates, for those of you who might still find it confusing. Okay, so I'll be seeing you in the next class. Please attempt the given assignment. For now, stay safe. Bye.